Assalamu alaikum. This is Miss Iman Ismail from Al Salt Maliki Private School, Head of Math Department and teacher for grade 10. Today we have topic 7, matrices and transformations. We will start with matrices. In this lesson, we will learn what is a matrix, rows and columns of a matrix, dimensions or order of a matrix, elements of a matrix, types of matrices, matrix addition and subtraction, and finally multiplying two matrices. In order to understand the concept of a matrix, it is a rectangular array of numbers arranged into columns and rows. Matrix algebra is used in statistics to express collections of data. For example, the following is an Excel worksheet with a list of grades for exam. You can see this sheet down. It is column of names and rows of marks, and we can represent it in capital G equals to the matrix. We put the marks in columns and rows as it's clear in the sheets. Here we have an example of matrix. It's included 3 rows, 6, 10, 5, 3, and 0, 2, and 2 columns, 6, 5, 0, and 10, 3, 2. Each number inside the matrix known as an element of the matrix. The dimensions or order of a matrix gives the number of rows followed by the number of columns in a matrix. So the order of the matrix above, it is 3 rows and 2 columns. It is 3 times 2 or 3 by 2. Here we have another example of a matrix. This matrix is C. The matrix C included 5, 9, 6, 0, 8, 1, 12, 3. These are all elements of the matrix C. We usually denoted a matrix by a capital letter. So C is a capital letter. C is a matrix of order 2 rows times 4 columns, and we read it as 2 by 4. Here we have types of matrices. Type number 1, we have square matrix. What's the meaning of square matrix? It means we have the same number of rows and columns. This one is 2 by 2 matrix. Means I have 2 rows and 2 columns. Sometimes we have 3 rows, 3 columns, 5 rows, 5 columns. So it should be same number of rows and columns. Type number 2, it's rectangular matrix. The number of rows here is different than number of columns. In this matrix we have 3 rows and 2 columns, and the order is 3 times 2. Type number 3 is zero matrix. This means all elements are 0. In this example we have 3 rows and 5 columns, and the order of this matrix is 3 times 5. Type number 4, we have row matrix. This means the matrix included 1 row only, but the elements, it depends on the matrix. In this example, we have row matrix 1 row and 4 columns. So the order of this matrix is 1 by 4. Type number 5, we have column matrix. This matrix included one column only. So in this example, we have the matrix 1, 2, 6. It has one column and 3 rows only. So the order of this matrix 3 by 1. Type number 6 is an identity matrix. It is a square matrix having ones on the main diagonal and zeros everywhere else. For example, here we have 3 by 3 identity matrix. Let's cover the kinds of math operations we can do. We can do addition and subtraction. Matrix addition and subtraction is the same as number addition and subtraction. We add or subtract number by number because we have to match our number to number. Our two matrices must be the same size like this. So here we have two matrices and the order is 2 by 2. We can add them correctly. So we will add 1 plus 2 equals to 3, and 2 plus 5 equals to 7, 3 plus 7 equals to 10, 5 plus 9 equals to 14, as it's shown below. As we mentioned before, we said matrices must be the same size to add or subtract. Here we have an example of subtracting matrices. We have two matrices, same size, both of them 2 by 2, and we subtract the numbers 1 by 1. So the example here, 3 minus 4 equals to -1. 8 minus 0, it will be 8. 4 minus 1, it will be 3. And 6 minus -9, it will be 6 plus 9. So the answer will be 15. Okay. Now we have multiplying two matrices means rows hit columns, means rows multiply by columns. To understand the general pattern of multiplying two matrices, think rows hit columns and set up rows. Consider the following example. The first row hits the first column. So the first row is -1, 4 multiplied 9, 6. Okay? Giving us the first entry of the product. Notice that since this is the product of 2 by 2 matrices, a number of rows and columns, the result will be also 2 by 2 matrix. We will look at how the size of the matrix affects this later in the article. So look at the two matrices below. -1 multiplied by 9 plus 4 multiplied by 6. Now the first row hits the second column, filling up the row of the product. So the same row we noticed before. The same row now hitting the second column. Okay, so -1 multiplied by -3 plus 4 multiplied by 1 in order to fill up the row of the products. Having run out of columns to hit, we now work with the second row. Okay, what's the second row? It's 2, 3. So second row multiplied by the first column will be 2 times 9 plus 3 times 6. There is one last entry to calculate. The second row will now hit the second column. What's the second row? It's the same row we used before. It's 2, 3. So the row 2, 3 will hit the column negative 3, 1. The operation will be 2 times negative 3 plus 3 times 1. Finally, we just need to complete the arithmetic to get our final answer. So, negative 1 times 9 will be negative 9 plus 4 times 6, it will be 24. So, negative 9 plus 24, it will be 15. Okay? Then, negative 1 times negative 3, it will be positive 3 plus 4 times 1, it will be 4. So, positive 3 plus 4, it will be 7. This is the second element. The third element, it will be 2 times 9 plus 3 times 6. 2 times 9 will be 18 plus 3 times 6, it will be 18. So 18 plus 18 will be 36. And the last number or the last element in the matrix will be 2 times negative 3, it will be negative 6 plus 3 times 1, it will be 3. So negative 6 plus 3 will be negative 3. So our matrix will be 15, 7, 36, negative 3. This is the final answer. Greetings and thank you very much. This is Miss Iman Ismail from Al-Sat bin Malik Private School.